Okay, here's another volume revolution. This time, which way are the cross sections going? Are the cross sections perpendicular to the y-axis, or are they perpendicular to the x-axis? You know by looking at where the axis of revolution is. So it says the solid is generated by rotating r about y equals 4. So this is where it's rotating. Okay, we're rotating that axis. So that means our circles are going to go like from here. Say we'll draw out in front and then behind it. Okay, so that's how it's going to look, right? Okay, so how are we going to figure this one out? Well, let's do our steps just to go, to keep it in order. Let's do our integral first. So is this integral with respect to x or y? The answer is x because we are perpendicular to the x-axis. Wherever we're perpendicular to, that's what we do our integral of. Okay, now let's see. How are we going to find the radius? Well, actually, better question, what are my x's? What's my lower bound and upper bound? It looks like my lower bound is 0, and then my upper bound is right here at 2. Okay, we're rotating around the y equals 2. All right, so we have to find our area function in terms of x. Our area function, we know, is pi r squared. But we can't have the r there. We have to rewrite the r so that it's in terms of x. So how do we find this length right here? How do we find the length from the center of the circle to the end of the circle? Well, the center of the circle is at 4. Y equals 4. Where is this point located at? How is that defined by x? X squared. So we're going to subtract x squared. We go we're supposed to go outer minus inner. That doesn't work if we go like that. We have to go the outer minus the inner one. So it would be outer x squared minus the 4. This would equal your r. Actually, I'm sorry. It should be 4 minus x squared. But it doesn't matter. Like this would give you a negative r and this would give you a positive r. But why does it not matter? It doesn't matter because there's a squared right here. So let's plug it in. I'm going to do the axis minus the x squared and then square it. And it's multiplying times pi. So we're going to integrate this. We're going to plug that into there and then we're done. Okay, so we get our third step is to integrate. We're going to go 0 to 2. And put the pi on the outside, and I'm going to put 4 minus x squared on the inside, where I'm going to square it, and then dx. So I get 4 minus x squared times 4 minus x squared. I get 16 minus 2x squared minus plus x to the 4th dx. And we have our pi on the outside, 0 to 2. The integral of, or the antiderivative of 16 is 16x. And then we're going to subtract 2 over 3x to the 3rd. And then plus 1 over 5x to the 4th. And we're going to plug in 2 and 0. And when we're all done, we're going to multiply it by pi.
Is it negative 8x squared or negative 2x squared?
Ooh, negative 8. Where do you see the negative 8 at?
For 16.
All right, so found a mistake here. Thank you, Lilibeth. We have the 16, but this is a negative 4x squared, and this is a negative 4x squared. So this should be an 8, not a 4. So we have minus 8x squared, which changes this guy right here. So we're going to put that as 8 over 3. Thank you for the catch. All right, so now I'm going to plug in the 2. They're all multiplied by x. So when I'm plugging the 0, it's just going to go away. So I really only have to plug in the 2. So we have pi times, wait, I'm missing a, yeah. Wow, second mistake. That's supposed to be a 5. Thank you, Sam. Good catch. Okay, so 2 times 16 is going to be 32 minus 8 over 3 times 8, because that's 2 to the 3rd power, plus 1 over 5 times, what is that? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I got 32. Hopefully I'm right. I'm like on a roll for making mistakes here. Okay, and now simplify time. Oh, this is nasty. Okay, so we have 32 over 5. This would be 64 over 3. And that would be 32. And we have to multiply that by pi. Okay. And I think, I think we can actually leave the answer like that, but I'm not going to. I'm going to simplify it. All right, I double checked, and Khan accepted it. As they should, because the College Board would accept that also. That's your answer.